All right, guys, so we're going to go through section 1.1. So what ended up happening earlier was I did this in my face-to-face class, and I had hit record, and something happened, and it wasn't recording. So I'm going to go through it again. But if y'all got any questions, please let me know, and this will be obviously in our YouTube page. So section 1.1 is mathematics and problem solving. So we're going to try to understand and explain something called the four-step problem solving process. How to solve problems using various problem solving strategies. So we got a couple of steps. The four-step problem solving process says, number one, we got to understand the problem. Number two, we're going to figure out how to plan. Number three, we're going to carry out that plan. And number four, we're going to look back and say, hey, do we notice any things? Okay. Let's see. So understanding the problem, can we state the problem differently in maybe better terms or easier terms for us to understand? What are we looking for and what do we need? What are the unknowns? What information do we already have? And part E is really important. What information, if any, is missing or it's not really needed? Sometimes they give us info that's not really necessary for our problem. So in part of devising the plan, we're going to look for a pattern. Sometimes we look at a problem that we've already done and see if we can make the current problem one like we've already solved before. We're going to examine a simpler or a special case of the problem. Sometimes we make a table or a list. We identify something called a sub-goal. Sometimes we make a diagram. Sometimes we just guess and check. Sometimes we work backwards. We'll write an equation. Okay. And carrying out the plan. So let's implement the strategy and perform any necessary actions or computations. Attend to precision in language and mathematics used. Check each step as we keep going on and keep an accurate record of our work. Looking back, check the results in the original problem. Interpret the results in terms of the original problem. Does our answer make sense? Is it reasonable? Is there another solution for finding, another method, for finding a solution? If possible, can we determine other related or more general problems for which the strategies will work? Okay, so strategies for problem solving. Strategies are tools that might be used to discover or construct the means to achieve a goal. Because problems may be solved in more than one way, there is no one best strategy to use. Sometimes strategies can be combined in order to solve a problem. All right, so here's the first problem here, y'all. It's called Gauss's problem. And it says when Carl Gauss was a mathematician, born a whole long time ago, right? I don't know exactly when. Was a child, his teacher required the students to find the sum of the first 100 natural numbers. The teacher expected this problem to keep the class occupied for some time, and Gauss gave the answer almost immediately. How did he solve the problem? Okay, so understand the problem. The needs of the natural numbers. Natural numbers are what we call the counting numbers, okay? 1, 2, 3, 4, so on and so forth. The idea here is we're looking for this sum. We're trying to add 1, 2, 3, all the way to 100. Okay, so this is how he did the problem. I'm going to show you guys. He said, look, I'm looking for the sum. I'm going to call it S for sum, right? Sum means to add 1 plus 2 plus all the way 99 plus 100. Okay, when we add up numbers, it's not important what number we add first or what number we add second. So if I were to rewrite this problem, but I were to start at 100 and then 99 and all the way down to 2 and to 1, if I were to add straight down, notice I'm not just getting the sum, I'm actually getting twice the sum. But 100 plus 1 is 101. 2 plus 99 is also 101. All the way, 2 plus 99 again, 101. And 100 plus 1 is 101. So he said, look, I'm adding up the number 101 a bunch of times. But when we do repeated adding, that's the same thing as multiplying. So we're adding up the number 101. Now we got to figure out how many times are we doing this? Well, how many numbers do I have as I go across? Well, we got 100 numbers. So we're adding up the number 100 times. Let me fix that again. So if I wanted to find the sum, I could just divide it by 2, right? Because I really had twice the sum. So the sum is going to be 101 times 100 divided by 2. And the answer is 5,050. And that's how we did that problem, okay? So this method of what we're doing here, guys, which is writing the sum out and writing it again, but in reverse order and adding straight down so that we get twice the sum, when we do that, those numbers are going to be the same. And then what we're figuring out is how many times are we adding up that number? And because we know that repeated addition is the same thing as multiplying, we said, look, we're adding it up 100 times. It's the same thing as multiplying by 100. But because that was double the amount, we had to divide it by 2. That process is called Gauss's method. Okay, and we're going to do that for the next couple of problems. Okay, so I'm going to do part A right here. And part A says, use the approach in Gauss's problem, which we just did, to find the following sums of what we call arithmetic sequences. Okay, so look, I'm going to write S for the sum. 1 plus 2 plus all the way down to 101. So notice the numbers are going up by 1. Okay, so the process says we're going to write it again, but in reverse order. Okay, so that now when we add straight down twice the sum, 1 plus 101, 102. 2 plus 100, 102. Right? And we're going to keep playing that game. So remember we said we now need to figure out, we are adding up the number 102 a bunch of times. How many times are we adding it up? Well, let's take a look. Writing it once, twice, we're adding it up, 101 times. Okay? But that actually gives me twice the sum. So to find the sum, we're going to divide it by 2. So 102 times 101 divided by 2. So I'm going to grab my calculator right here. 102 times 101 divided by 2 is 5151. Okay? So that's going to be my process. That's how I'm going to do all these problems. Okay? So now let's take a look at part B. Okay? So part B, the sum, what are we adding? Oh, we're going 1 plus 3 plus 5, all the way down to 999. Okay, so I need to figure out what's the number right before 999. Well, look, they're going up by 2. Okay, so this number here needs to be 997. Because when I go up by 2, I'll get up to 999. So remember what I'm going to do now. Excuse me. I'm going to rewrite it, but backwards. Starting off with the biggest number, and then the next biggest number, and then all the way back down to 1. So now when I add straight down, right, I'm adding straight down, that's going to give me twice the sum. Well, 1 plus 999 is 1,000, and 3 plus 997, excuse me, is another 1,000. And we're going to keep doing that right all the way to the end. All right. So now we have 1,000. We got to figure out how many times are we adding this up. Now, I can't just say we're adding it up 999 times because we're skipping the even numbers, right? We're not using the even numbers. We're going from 1 to 3 to 5 and so on and so forth. Now, there's a way we can figure that out. The way we can figure this out is, now remember, we already said the difference between each of those numbers there is 2. So I'm going to show you guys a formula. It's going to be 2 times n minus 1. And that's going to give me the value of each term. Okay, let me show you what I mean by that. That's the first term. That's the second term. So these are going to be my values of n. If this is my first term, I want to show you something. If I were to plug in n equals 1, 2 times 1 minus 1. 2 times 1 is 2. 2 minus 1 is 1. That's the value that I got right there. This is the second term. If I take 2 times 2 minus 1, that's going to give me 4 minus 1. That's 3. That's the value that I have right there. Okay? So now, if I want to figure out which term is that one, I can say 2n minus 1 equals 999. Add 1 to it. 2n equals 1,000. Oops. So when I divide both sides by 2, I'm going to get n equals 500. That is the 500th term. Okay, so I'm adding up the number 1,500 times. All right. So now what we're going to do is we're going to divide by 2 again. Okay, so take my calculator one more time. 1,000 times 500 divided by 2. 250,000. There's my answer for part B. Okay. All right, now let's see if we can answer part C. We're going to keep doing the same game here, y'all. Okay, look at part C. We got 6, 13, 20, all the way to 692. Okay, part C. The sum is 6 plus 13 all the way to 992. Okay, so I know the difference between those numbers is 7. So if I'm going to take my calculator, what's 992 minus 7? So I know what the term right before it is, 985. Okay. Now remember, I'm going to write this sequence again, but in the reverse order. 992, 985, all the way down to 13 and 6. Okay. So now, when I add straight down, that's going to give me twice the sum. 6 and 992 is 998. And that's also 998. And we're going to keep playing that game all the way down to the end. Okay. So I can say, look, I'm adding up the same number. So I'm adding up 998. Now I got to figure out how many times am I doing that. Okay. So remember what the formula is. The formula says whatever the difference between those numbers is, in this case it's 7, it's going to be 7n minus 1, always minus 1. And that's going to give me the value of the term, right? So again, just to show you one more time, remember that's the first term and that's the second term, right? So 7 times 1 would be 7. 7 minus 1 would give me 6. 7 times 2 would give me 14. 14 minus 1 would give me 13, right? So I can say 7n minus 1 equals 992. So when I add 1 to both sides, 993, and I divide both sides by 7, I get my calculator, 993 divided by 7. Oops. Oh, 982, I'm sorry. No, 992, wasn't it? Oh, 998, sorry. No, I'm doing this right. Did I do something wrong here? 692, sorry. Sorry. That's a mistake. It was 692. Okay, 692. So I knew I made a mistake somewhere. 692 minus 7 was 685. Okay. It's still 998 though. Okay, so 692. That's the only mistake we had. Let's fix this part right here. Sorry about that, you guys. 692. That becomes 693. So 693 divided by 7 is, there we go, 99. So we have 99 terms. We got 99 problems. The math is one of them. Let's divide both sides by 2. Just going to take my calculator again. 998 times 99 divided by 2 is 49,401. 49,401 is my sum, right? All right. So I think there is a part D to this problem, so let's figure out part D. There we go. Okay, so the first thing I want y'all to notice about part D here, y'all, is they already got it in reverse order. Okay, so let's figure out how much is it going up by or down by, however you want to say it. So let me take my calculator here. 881 minus 872 is going up by 9, right? So we can say, look, we can say 8, add 9, 17, 872, and 881, right, with all the little dots in the middle. Okay, so let's do that part. So D equals, or part D is, the sum is, where we starting off again, let me see, 8, 17, plus 17 plus all the way down to 872 and 881. Okay, so now I'm going to write down that sum again. I'm just going to write it in the other order. 881 plus 872 plus 17 plus 8. Okay, so twice the sum. Okay, 8 plus 881 is 889. And that's the number that we continue to add all the way down. Okay. So now I know that means that I'm adding 889, but how many times? So remember, the formula again is going to be what's the difference in those numbers? 9. N minus 1, right? So again, just to show you, I want to make sure you guys believe me. That's the first term, that's the second term. 9 times 1 is 9, minus 1 is 8. 9 times 2 is 18, minus 1 is 17. So 9 times 9n minus 1 is equal to 881. So if I add 1 to both sides, I get 9n equals 882. 882 divided by 9. There are 98 terms. Okay, so we're doing that 98 times. So now we can go ahead and divide everything by 2. Okay, 889 times 98 divided by 2, 43,561, right? Okay, so now let's keep going here. All right, next problem here says, let's find the sum, but I want y'all to notice something. We're starting at 48, 48, 49, 50, so on and so forth. So I want you to think about this for a little bit. Remember what it said. When I come back to looking at my strategies, let me see. Okay, it says, can we examine a related problem or make a simpler case or a special case for the problem? Okay, so this is exactly what I'm going to do here. Okay, so if I'm trying to add, here we go, 48 all the way to 117. Just like we did this first problem right here, and the way we did Gauss's problem right here is how I'm going to go about doing this one. I'm going to say, look, I'm going to call this sum 1. If I was adding these numbers all the way down to 117, I would know how to do that problem, right? And I would say, look, I'm going to rewrite it in the reverse order, right? And I'm going to say, what am I, twice the sum is going to give me 118 plus 118 all the way down to another 118. And I would have to ask myself, how many times am I adding up the number 118? And I would say, look, since they're all going up in order and I'm not skipping anything, I'm doing this 117 times. So then I would say, if I wanted to find sum 1, I would divide everything here by 2. So 118 times 117 divided by 2. Let's see what that's going to give me. 118 times 117 divided by 2 is 6903. Okay, so there's that part. All right, now I know that's not what I want, but I'm going to show you a process here. Now, suppose I call sum 2. Notice where I'm starting off here. I'm starting at 48. So I were to say sum 2. What happens if I were to add all the numbers all the way up to, say, right before 47? And I were to do that same process again, 47 and 46 and 2 and 1. And I could say twice sum 2 would be me adding up the number 48 a whole bunch of times, right? And I would say, well, how many times am I adding up the number 48? Well, since those numbers go in all order and I'm not skipping anything, I'm adding up that number 47 times. So to find the sum, I would just divide it by 2. And I would take my calculator again and say, what's 48 times 47? And divide it by 2. And I'd come up with 1128. And then I could say that if I wanted to find this sum, I could take all the numbers from 1 through 117 and subtract off the 1 through 47, and that will leave me with the 48 through 117. So I would take 6903 minus 1128. 6903 minus 1128, and that would leave me with 5775. And there's my answer, right? Okay, just want to make sure we're still recording, and we is. All right, second part. We're going to use something called making a table. Hold on, I get my water. Okay, making a table. All right, so it says it often uses strategy in elementary school math is making a table. The table can be used to look for patterns that emerge in the problem, which in turn can lead to a solution. All right, so look what it says here. Cookies are sold singly or in packages of 6 or 18. With this packaging, how many ways can we buy 36 cookies? Okay, let's figure this out. We can buy packs of 36. No, sorry, we can buy packs of 18. We can buy packs of 6, or we can buy packs of 1. That's what singly means. But in every case, we want the total to be 36. Okay, so 18. If I'm buying packs of 18, I can buy 2 packs of 18 because 2 times 18 is going to give me my total of 36. So I'm not going to buy any packages of 6. I'm not going to buy any single cookies. All right. I could buy 1 pack of 18. 1 pack of 18 is 18 cookies. 18 cookies from 36 minus 18 is going to leave me with still 18 cookies. I could buy 3 packs of the 6 because 6 times 3 is 18. I don't need any single cookies. Remember, I'm trying to get a total of 36 each ways. So what I'm really doing here, y'all, is I'm saying 2 times 18 gives me 36. So if I'm getting my 36 there, I'm going to have 6 times 0 and 1 times 0. If I do 18 times 1, that gives me 18. So I have to multiply 6 by 3 to get another 18 so I can get my 36. So this is what I'm doing. I'm making a table, but I'm going to try to do it systematically, meaning that the most packages of 18 I could buy was 2. Couldn't buy any more than 2 because I'm trying to get exactly 36. But once I figured out I needed 2 packs of 18, then I can say, what happens if I'm going to use 1 pack of 18? Okay, now I'm going to stick with 1 pack of 18. Instead of me buying 3 packs of 6, if I bought 2 packs of 6, then I need 6 single cookies to get to my 36, right? This is 1 times 18 is 18. This is 2 times 6, which is 12. This is 6 times 1. That gives me my 36. Okay? Or I could do 1 pack of 18, 1 pack of 6, and 12 single cookies, and that gives me my 36, right? Or I could buy 1 pack of 18, no packs of 6, and 18 single cookies, and there's my 36. Okay. Now, if you notice, when this number here was 1, look, this was 3, it's going down by 1. When that's going down by 1, because these are sold 6 in packs of 6, they're going up by 6, right? All right, so I'm going to keep playing this game here. Okay. Now, what happens if I bought no packs of 18? Then I would need 6 packs of 6, none of the singles, and there's my 36 cookies. Or I could buy 5 packs of 6 and then 6 single cookies and 36, right? I want you to start noticing the pattern. 0, 4, and 12, 0, 3, and 18. These are going down by 1. These are going up by 6. 0, 2, and 24. 0, 1, and 30. 0, 0, and 36. And what we've done is we've done this in a table, but we did it systematically. What I mean by that, y'all, is this first number was 2. I was using the biggest package of cookies I had and figuring out how many of the big packs do I need to get to my 36. Once we figured out we didn't need more than 2, then we said, let's go through each of the case scenarios where we only need 1. And let's go through each of the case scenarios where we don't need any of those big packs. And we're reducing these as we go through as well. And again, instead of me kind of skipping around, I'm trying to do it in order, right? Now the question was, how many ways can we do this? So we're just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we came up with 12 ways on how we can do that. Okay. Let's see. All right, so the next problem here says, shown to the right is a magic square. All the rows, columns, and diagonals sum to the same number. Find the value of each letter. Okay, so what does that mean? When it says that they sum the same number, whether I add going left to right, or whether I add going up and down, or even if I add on the diagonal, all those should always be the same number. So first thing I notice is if I go along the diagonal, I got all three of those numbers. So let me take my calculator here. And let's see if we can add them up. So 8 plus 17 plus 26, okay? That's going to give me 51. So all these things, whether I add up and down, left and right, doesn't really matter. Always going to add up to 51. Okay, so let's do this. 51, 51, 51, 51, 51, 51, so on and so forth, okay? What we're trying to do is we're trying to find the value of the missing letters. Okay, so if I wanted to say find the value of A, what would we do? We would say, look, let's take 8 plus 18. So we'll clear this out. 8 plus 18. That's going to be 26. Okay, so we're going to take 51 minus 26, and that's going to leave me with 45. So A is going to be 45. Okay, let's do the same thing for B. Okay, so I'm going to take 27 plus 17. Oops, 44. Okay, so what's 51 minus 44? That's going to give me 7. All right. Let's see if we can figure out C. Man, I can't do C going left and right, but we can do C going up and down. What's 8 and 27? 8 plus 27 is 35. So 51 minus 35 is going to give me 16. So that's going to be 16. Okay. And if we wanted to figure out the value of, say, D, we know now that's a 16. Couldn't I take 16 and 26? 42. So what's 51 minus 42? D is going to be equal to 9, right? And we got each of our values, okay? All right. Next problem here says, Audrey and Lauren began reading a novel on the same day. Audrey reads 14 pages a day and Lauren reads 4 pages a day. If Audrey's on page 56, on what page is Lauren? Well, let's see. Audrey reads 14 pages a day. So Audrey is 14 pages per day, and Lauren is 4 pages a day. Okay. Now, we know that Audrey's on page 56. So she's on page 56. I'm trying to figure out how many days did she read to get to 56? Well, we could take 56 and we could divide it by 14, and it took her 4 days to get there. Okay. Now remember, they started reading on the same day, so we know that's going to be 4 days as well. So she's going to be on page 16, right? So Lauren will be on page 16 when Audrey's on page 56, okay? All right. Next one here says, the 14 digits of a credit card are written in the boxes shown. If the sum of any 3 consecutive digits is 16, what is the value of A? Okay, so first off, remember what sum means. Sum means we are going to add. Consecutive means right next to each other, like these 3 boxes right here. If I add them up, I need to get the number 16. So 6 plus 3, I already know that's 9. So what do I have to add the 9 to get to 16? I got to add a 7. So that number there is going to be a 7. Okay. Now, same thing is going to happen if I go over here. Well, what's 6 and 7? 6 and 7 is 13. How much do I have to add to 13 to get to 16? I got to add a 3. Okay. Well, we're going to do the same thing here. If this is a 3 and a 6, so that's 3 and 6, that's 9, that has to be a 7, right? And if this is 10, that has to be a 6. And what I start noticing here, y'all, is we got a little bit of a pattern, don't we? 673, 673. Oops. Like that. 376. So right before the 6 is a 3, and right before the 3 is a 7. So the value of my A there is a 7, right? And I'm just doing a little pattern. 673, 673, 673, 673, right? If there's a 3 here, right above, right in front of the 3 is a 7. There's my 7. Okay. All right. So we're almost done here. Katie stood on the middle rung of a ladder. She climbed up 4 rungs, moved down 5, climbed up 7, and then climbed up the remaining 2 rungs to the top of the ladder. How many rungs are there in the whole ladder? I don't know, but let's do this. We'll say there she is. She's in the middle. Okay. Now it says she climbed up 4 rungs. So 1, 2, 3, 4. Okay, then she moved down 5. 1, 2, 3, 4, one more, 5. Then she climbed up 7. Okay, 1, 2, 3, 4, 5, 6, 7. Then she climbed up 2 more and she got to the top. How many rungs are on the whole ladder? Well, let's take a look. If this is the middle right here, let's count how many to the top. 1, 2, 3, 4, 5, 6, 7, 8. So if it's 8 to the top, then it's got to be 8 to the bottom. There's got to be a total of 16. Okay. All righty. So now the question says, find the value of the question mark, meaning what's going to be the value right there. So take a look. We got a burger, another burger. That adds up to 30. Each of the burgers got to be 10. So we'll go like this. A burger is 10. So if this is 10 plus, I don't know what those are, hot dogs or whatever, those are 18. So I know that this means this part right here, the 2 hot dogs, plus another 2 hot dogs, got to add up to 8, right? Because that's already 10. So that means that the double hot dog is going to be 4. Okay. Well, if the double hot dog minus the double soda is 2, right? So that's going to be 4 minus the double soda is equal to 2. So by minus 4 and minus 4, that means the negative double soda, I'll figure that out in a minute, is a negative 2. That means that the double soda is a positive 2. Well, if the double soda is a positive 2, then a single soda is going to be a 1. And a 1 plus a burger, which is a 10, it's got to add up to 11. Okay, there's my question mark, 11. All right, let's see. We got a little bit more. Yes, we do. A few more problems here, y'all. So it says, suppose you could spend $6 every hour, night and day. How much could we spend in a year? Okay, so $6 an hour, right? $6 per hour. If I multiply that by 24 hours, because there's 24 hours in a day, 6 times 24, $144 in a day. Okay. Now, if I'm spending $144 in a day, it says how much can we spend in a year? And it says there's 365 in a year. So we're going to go 144 times 365 times 365 is 52,560. That is my choice B right there. Okay. Let's see. It says a pencil box and a notebook together cost $6.48. The notebook cost 70 cents more than the pencil box. How much did the notebook cost? I don't know. All right. So look, y'all, when we're doing these problems, we have a pencil and we have a notebook, right? And we know how much they cost together. When they describe the cost of the notebook, they describe it in regards, or they compare it to the pencil box. I don't know anything about the pencil box. The one that we don't know anything about is going to be our value. We'll call it X. Pencil box, right? Now, that the notebook is 70 cents more than that. So whatever that is, add 70 cents, and that's how much the notebook is going to cost. Okay. Now, together, it costs $6.48. So that means a pencil box, which is X, plus the notebook, which is X plus 0.70, has to add up to $6.48. So look, we got two things. There's two X's. What I'm going to do now is I'm going to subtract 70 cents. So $6.48 minus 70 cents is $5.78. And we'll divide everything by 2. Okay. And that's giving me $2.89, right? Now, before I go and start marking my answer, I want to remember what X stood for. X was the pencil box. So the pencil box is $2.89. Remember, the notebook is 70 cents more than that. So if I add 70 cents more, that's $3.59. Now, the reason I wanted to do that is the question actually says, how much does the notebook cost? Well, look, the notebook costs $3.59. Had I stopped here and looked at my answer, I would have probably marked B without realizing they were actually looking for the other part, right? So just you want to be careful in regards to that. Okay. And we're still good here. All right. A drink and a sandwich together cost $5.45. Okay, let's take a look at this part. Sandwich is $2.45 more than the drink. So the drink is going to be my X. So the sandwich is X plus $2.45, right? Together, it's $5.45. So X plus $2.45 is $5.45. So X and X is a 2X, and we're looking for two things here. And so now I'm going to subtract here. That's going to give me $3. And I would divide them both by 2. That's going to give me $1.50. And so what is $1.50? Well, $1.50 is my drink. So my drink is $1.50. Now my sandwich is $1.50 plus another $2.45, which is 1.50 plus 2.45, $3.95. Okay. And the question says, how much does the sandwich cost? Hey, the sandwich is at $3.95. All right. So again, had I stopped here, I might have chosen that and I would have got the answer wrong, right? Because that's not what they're looking for. All right. So it says a rectangular field is to be enclosed with 1,270 feet of fencing. If the length of the field is 75 feet longer than the width, then how long is the field? I don't know. Let's see if we can't figure that out. So first thing is, it's a rectangular field. So the field is going to look like that, like a rectangle, right? And suppose we call this the width. The length is 75 feet more than the width. So that's going to be X plus 75. It's more. And I know that's got to be X2, and that's got to be X plus 75. And we're going to put a fence around the whole thing, right, like this. And that fence is going to be 1,270 feet. So look, we can say that X plus 75 plus another X plus 75, because I'm adding up all the way around, right? Starting from here, going all the way around. That has to add up to 1,270. Okay, so look how many X's I got. I got 4X. 75 and 75 is 150 equals 1,270. Okay, now I'm going to subtract 150 on both sides. All right, so 1,270 minus 150 is 1,120. I'm going to divide everything here by 4. So divided by 4, 280. Okay, so what does that tell me? That's telling me that this piece right here is 280, but the top part is going to be 280 plus 75. So the bottom piece down here is going to be 355. Right? And the question is saying, how long is the field? It's 355 feet, right? Now, today in class, I didn't get to this last problem, so I'm going to do it on Wednesday. It's a pretty straightforward problem, and I think a lot of you guys can figure it out. But on Wednesday, when I'm in my in-person class, I'm going to start right here, and then we'll continue with 1.2. All right. So I just want to let you guys know that's why I'm stopping where I'm stopping.